Hi, Algebra 2 Trig students. Happy Thursday. Sorry I cannot be in class again today, but hopefully today runs smoothly. Hopefully you just have finished watching the YouTube video introducing sine and cosine graphs, and now I'm going to just take it step by step and we can follow along a little bit with some things that you might have learned in the video, along with some things that will be new for us for today. So we should be taking a look at our day 17 notes. I apologize. Before I was out, I had made these, but I believe I updated that on your Google form. So today we're going to construct ourselves a picture of sine and cosine functions. We're going to be using inputs and output tables to create these two graphs. And we're also going to be using our knowledge of the unit circle. So one thing that we talked about in the video is this idea that the unit circle is just a way to house the information. It's not actually the graph, right? So if we think about working our way around the graph, or the unit circle, let's talk about some benchmark angles. So here at 0, and we're going to start off with cosine or sine first. So here at 0, the y value is 0. So remember, here is our inputs. Here are our outputs, right? And then if we move up to pi over 2, the y value at pi over 2 is 1. The y value at pi is back to 0. The y value at 3 pi over 2 is negative 1. And the value at 2 pi is back to 0. Now, it's important to keep this in mind that we always, and I'll move the screen in a second, we always scale our graph in radians. Let me hide that screen for a second. Okay, we always scale our graph in radians, so that's important to keep in mind. And we always want to add arrows in our graph to think about constantly moving around a circle. Okay, so remember that very first day when we started talking about the unit circle, and we said that the unit circle is not the graph, it just stores all the information. And I think I had you guys make a circle with your hands, and we broke it apart and then rotated our wrists, and that kind of created this curvy line. And that is exactly what the graph of sine and cosine looks like. Now, if we take a look at this graph right here, we notice that our highest value is 1 and our lowest value is negative 1. And if you think about it, that is because of the radius of the unit circle, right? We were only looking at a radius of 1. So our amplitude, which we'll talk about in a few minutes, is just going to be from 1 to negative 1. So our amplitude is just 1. And if we take a look at our scale, right, here's our scale of theta, our inputs, and here's our y values, our outputs. And if we look at it, it is scaled in degrees. So we want to make sure that we scale that in radians. So we're going to make sure that this is pi over 2. We're going to make sure we know this is pi. We're going to make sure we know this is 3 pi over 2, and then 360 degrees is 2 pi. And if you wanted to keep going around and around and around, you obviously can then add those coterminal angles, like 450 degrees would be coterminal to pi over 2, 540 would be coterminal to 180, and so on and so forth, but we're not quite there yet for today. So now if we want to go ahead and start graphing, here at 0, our y value is 0, so we can just go ahead and plot that point right here. Here at pi over 2, our y value is 1. Here at pi, our y value is back to 0. Here at 3 pi over 2, our y value is negative 1. And then here at 2 pi, our y value heads back to 0. Now, some of the values up here are listed with their decimal approximations, right? So 1/2 is 0.5, root 3 over 2 is 0.86, and then root 2 over 2 is 0.7. And that's going to help us kind of determine like what's going on. For example, you can say that maybe pi over 2 would fall right here, smack dab in the middle. Maybe pi over 6 would fall here and pi over 3. So if we were to approximate like where those values would be, pi over 2, pi over 4, so pi over 6 had a sine value, so that's right here, 30 degrees, had a sine value of 1/2. So maybe we would plot that, let's see, 1, 2, 3, 4, 5. So we'd plot that about like right here. Okay, pi over 4 had a sine value of root 2 over 2. So maybe that falls like just like a little bit right there. And then pi over 3 had a sine value of 0.86. So if you take a look, it's not perfect, but it kind of does create this arch-like looking shape that then as you plot your points and sketch from y value to y value, it does create this curvy-like shape. Now remember, we talked about how we always want arrows at each end because we do want it to mimic that movement of it constantly looking about the circle. So let's kind of talk about some thinking questions here. Is it pointy? Is it curvy? The answer is that it's curvy. Okay. And the reason why it's curvy is because we want to look at this idea of quadrants, right? So for example, here at pi over 2, all of this information looks like quadrant 1, right? And then here at pi, all of this information looks like quadrant 2. And then here at 3 pi over 2, all of that information comes from quadrant 3. And then here, when we get to 2 pi, all of this information looks like quadrant 4. So if you think about it, what are your sine values in each quadrant? Well, in quadrants 1 and 2, both of our sine values are positive, right? Positive, positive, negative, positive. But in both quadrants 1 and 2, our y values are positive, which makes sense that our graph sits up here in terms of positive numbers. And then if you think about quadrants 3 and 4, both of the y values are negative, which makes sense why the values down here fall below where y is 0, which gives us negative numbers. So that is the graph of sine. Now, in the video, he talked about some other vocabulary words that when we get into the graph of cosine, we'll cover more. But that is pretty much it in terms of sine. And tomorrow we will be talking more about like how we can sketch them, how there's different amplitudes, different periods, different rotations around the circle that we can graph. But let's take a look at the graph of cosine. Okay, so remember theta is always going to be our input. Okay, cosine of theta is always going to be our outputs, what we formerly knew them as x and y values. Okay, so when we think about moving around the circle, when we are at 0, the x value at 0 is 1. So notice we're starting in a different spot than sine. So we can think about that. Starting at different spot than sine. Okay. At pi over 2, our x value is 0. At pi, our x value is -1. At 3 pi over 2, our x value is 0. And then at 2 pi, we are back at +1, right? So if we take a look at rescaling this, here we know we have a max value of 1, a minimum value of -1, totally fine, right? We knew that. We know that 90 degrees is pi over 2. We know that here is 0. We know that 180 is pi, 270 is 3 pi over 2, and 360 is 2 pi, and we can go ahead and we can graph that. So we know that when x is 0, our y value is positive 1, so we're actually going to start up here. We then travel down to 0. We travel down to negative 1, and then that's where it starts to shift back up. Then we head back up to 0, and then we end at 2 pi back at 1. And notice you always start and end at the same spot because 0 and 2 pi are coterminal. So again, this is curvy, so try your best to sketch it a little bit curvy. And then we always have arrows on either end of that. Okay, so notice we start at positive 1, right? A few things to make note of if you think about these values, right? 1/2 is 0.5, root 3 over 2 is about 0.86. So if we were to do that idea again, we have pi over 6, pi over 4, pi over 3. Okay, the x value at pi over 3 is root 3 over 2, so that falls about right here. The x value at pi over 4 was root 2 over 2, and that falls about like right there. And then the x value at pi over 3 was 1/2, and that falls about right there. So they all do kind of like in line with what their approximation and decimal values are. Now this, we don't see it, but it does keep going and going and going and going for forever in both directions. But let's kind of break this up by quadrants again, and let's see if we're on the same page. So here are our 4 quadrants. I'm just using a yellow highlighter. Feel free to use a different color in Cami, right? But here's quadrant 1, here's quadrant 2, quadrant 3, quadrant 4. And if we think about the 4 quadrants, our x value is positive and our y value is positive in quadrant 1. So look, all of our values are positive. Beautiful. In quadrant 2, our x values are negative and our y values are positive. Well, if you take a look in quadrant 2, our x values are negative. Matches. In quadrant 3, both x and y are negative. That matches right here. Okay, x is negative. And then in quadrant 4, x is positive and y is negative. And there you go. In quadrant 4, x is positive. So it does follow that suit. Now, a few things that we didn't talk about in sine on the first page, but we can talk about here with cosine. And you can talk about it in both spots. It's just that, you know, now that we kind of have a little bit more understanding of this, I'm going through this a little bit quicker. But we always have the ability to talk about domain and range. Okay, our domain this time is talking in terms of theta, and our range this time is talking in terms of sine or cosine of theta. But basically, our domain is all real numbers still. Okay, you can talk about thetas in terms of infinity to negative infinity. And our range is very, very, very specific. Notice we only travel from -1 to +1. So we would never have anything that goes above +1. We'd never have anything that goes below -1. Now, some vocabulary words that we are going to talk more about tomorrow when I'm back in class with you guys is we have this word amplitude. And this goes for sine and cosine graphs. I'm just putting this on the back page, okay? And we also have this word period, which refers to the periodic of the graph. So the amplitude is the distance above or below the midline. So we would say in both the example of sine and cosine that our amplitude is 1 because from 0, which is our midline, we're going a +1 up and we're also going a -1 down. So we wouldn't say that the amplitude is -1 to 1. We would just say that it's 1 because you're 1 distance away from 0. Okay, and the period is essentially how long it takes to have one full rotation. right? So what we mean by that is always think about where you start and then how long does it take you to finish in that exact same spot. So for us, we start here at 1, and it takes us all the way until 2 pi to then repeat that value for us to go back to the beginning. So in our case, our periodic is 2 pi, okay? And it's important to keep in mind with this idea that sine and cosine functions are periodic functions. Okay. And an example of periodic functions, like think of a hamster on a wheel. It's running, it's running, it's running. It's continuously doing the exact same thing over time. That's exactly what these graphs do. These graphs are wavelengths, sound lengths, like sound waves, water waves. Like if you are interested in studying any type of engineering, this is all sine and cosine graphs. They're just constant coils that keep repeating each other. So that is our notes in a nutshell for today. So between the YouTube video that you watched and now this video that you've just watched with our notes, hopefully we have a little bit of some understanding of sine and cosine graphs. Again, this is the graph of cosine, and then this is the graph of sine that we covered. Notice amplitude is 1, periodic is also 2 pi, so they share the same, okay? They just start and end in different spots. It's curvy. We think of like the outer arc of a circle. It matches, right? This is not always the best sketch, but it is some sort of curvy line. So with that, I hope you guys have a really great day. I hope that these notes you find interesting. And if not interesting, you're trying your best, and that's all we can ask of you. And I will see you tomorrow in class on Friday. Goodbye, goodbye.